Consider the statement that if Marlowe submits her final assignment, then she will pass the course. This is an example of what logicians call a conditional statement, or simply a conditional. Some very common forms of reasoning involve conditionals. For example, there's a common form of reasoning which goes by the Latin name modus ponens, which goes, if A is true, then C is true, and indeed A is true, thus C is true. There's a form of reasoning which goes by the Latin name of modus tollens, which goes, if A is true, then C is true, but C is not true, thus A is not true. And those are just two examples. We could give more. So conditionals play a big role in reasoning. Now, we can see a conditional as built up out of two other statements. First, there's the if statement, which in our example is that Marlowe submits her final assignment. We call that the antecedent of the conditional. And second, there's the then statement, which in our example is that Marlowe will pass the course. We call that the consequent of the conditional. Now, here's a question. Is the truth value of a conditional determined by the truth values of its antecedent and consequent? So, for instance, take the example that we've been working with. If we plug in truth values for the antecedent and consequent, which could be true, 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 false, false, true, or false, false, does that automatically yield a truth value for the whole conditional in each case? It's actually quite a heavily disputed question within philosophy. Even ancient Greek logicians argued about it thousands of years ago. It's not a debate that we're going to spend a whole lot of time on, at least relative to how much time could be spent on it. But here I just want to step back and explain why it's an important question. And the reason it's an important question is that if the truth value of a conditional is determined by the truth values of its parts, then that makes conditionals just like conjunctions and disjunctions and negations in that respect, which means that we can use a truth table to assess the validity of arguments that consist not just of conjunctions, disjunctions, and negations, but which incorporate conditionals too. By contrast, if the truth value of a conditional isn't determined by the truth values of its parts, then the truth table method for assessing validity can't be extended to reasoning that includes conditionals. So let me spell that out a bit. So consider the following inference. At least one of Putnam and Quine is a logician. It isn't the case that while Putnam is a logician, Quine is not, so both Putnam and Quine are logicians. Is this inference valid? Here's how the truth table method for answering that question works. Consider the first premise. Its truth value is ultimately determined by the truth values of two more basic statements, namely the statement that Putnam's a logician, which we can label P, and the statement that Quine is a logician, which we can label Q. The first premise is just the disjunction of those two statements. Now consider the second premise. Its truth value is also determined by the truth values of those same two basic statements. It's the negation of the conjunction of P with the negation of Q. Finally, the same may be said of the conclusion. It's simply the conjunction of P and Q. Now consider the following possibilities. One possibility is that the two more basic statements P and Q are both true. Another possibility is that the first is true and the second is false. Another is that the first is false and the second is true. And another is that both are false. That covers all the possibilities. Any possible situation has to fall into one of those four buckets. So in order to tell whether there's any possible situation where the premises are true and the conclusion is false, we can follow these steps. First, consider the first type of possible scenario where both statements P and Q are true. Because the truth value of the first premise is determined by the truth values of those two statements, we know what the truth value of the first premise would be in any situation of this first type. Likewise, because the truth value of the second premise is also determined by the truth values of P and Q, we know what its truth value would be in any situation of this first type. And because the truth value of the conclusion is also determined by the truth values of P and Q, we know what its truth value would be in any situation of this first type. So because the truth values of the premises and conclusion are ultimately determined by the truth values of those two more basic statements, P and Q, we can say definitively what truth values the premises and conclusion would have in any possible situation of this first type. Indeed, because the truth values of the premises and conclusion are ultimately determined by the truth values of P and Q, we can say what truth values the premises and conclusion would have in any possible situation of the second type, what truth values they would have in any situation of the third type, and what truth values they would have in any situation of the fourth type. If all the premises would be true and the conclusion false in situations of the first type, or the second, or the third, or the fourth, then we can conclude that there are possible situations where the premises would be true and the conclusion false. Hence, we could conclude that the inference is not valid. By contrast, if we don't have all the premises turning out true and the conclusion turning out false in any of those four types of possible scenarios, then we can conclude that there are no possible scenarios at all where the premises are true and the conclusion is false. Hence, we can conclude that the inference is valid. In fact, in any situation of the third type, where P is false and Q is true, both of the premises are true and the conclusion is false, so we can conclude that the inference at issue is not valid. But now consider the following inference, whose first premise is a conditional. If Marlowe submits her final assignment, then she will pass the course. Marlowe will not submit her final assignment, so Marlowe will not pass the course. Is that valid reasoning? Well, first, consider the conclusion. Its truth value is determined by the truth value of a more basic statement, namely that Marlowe will pass the course, which we can abbreviate R. The conclusion is just the negation of R. Next, consider the second premise. Its truth value is also determined by the truth value of a more basic statement, namely that Marlowe will submit her final assignment, which we can abbreviate S. The second premise is just the negation of S. So as soon as a truth value is assigned to both of those more basic statements, S and R, and the options are again true, 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 false, false, true, and false, false, that settles the truth values of the second premise and the conclusion. But what about the first premise? That premise is in a sense composed out of the two more basic statements, S and R. S is its antecedent, and R is its consequent. But is the truth value of the first premise determined by the truth values of those two more basic statements out of which it's composed? If the answer is yes, then we can work out what the first premise's truth value would be in each type of possible situation, which would then allow us to determine whether there's any possible situation where both of the premises are true and the conclusion is false. However, if the truth value of the first premise is not determined by the truth values of its antecedent S and its consequent R, then we're stuck. We can still divide all possible scenarios into scenarios where both S and R are true, scenarios where S is true and R is false, scenarios where S is false and R is true, and scenarios where both S and R are false. Every possible scenario still has to fall into one of those four buckets. But the problem arises when we try to say what the truth value of the first premise would be in each type of scenario. If the truth value of that premise isn't determined by the truth values of S and R, then we can't say what its truth value would be in each type of scenario we've identified. So we wouldn't be able to say whether in any of those four types of possible scenarios, both premises are true while the conclusion is false. So if the truth value of a conditional is a function of the truth values of its parts, then we can just throw conditionals in with conjunctions and disjunctions and negations. We get to extend the truth table method for assessing validity to reasoning that now involves conditionals in addition to those other types of statements. But if the truth value of a conditional is not a function of the truth values of its parts, then that's off the table. So that's why it's an important question whether the truth value of a conditional is simply a function of the truth values of its antecedent and consequent. The answer to that question determines whether the truth table method will still work when we start looking at reasoning that involves conditionals.